Hello, my name's Andy Connell and you're watching a screencast on data modelling produced as part of the Business Systems Analysis course. Inside the screencast we're going to be focusing on entities, the attributes that describe them, and the relationships which exist between entities. Now, before we start, I want you to think about what data is. Data is pieces of information which are relevant to the system, which are going to be subsequently manipulated by programs. I want you to think about what the data represents. I want you to think about how it is to be described, and I want you to recognize the fact that some bits of data have relationships, but not all data is related to every other bit of data. So we're going to go through this looking at data, attributes, and relationships. So here they are. Entities, data. If we're talking about data in terms of databases, entities are sometimes called tables, aka otherwise known as a table. Attributes are also items of data, but at a lower level. In database terms, they're called fields, aka fields. It can be quite tricky determining whether a piece of data is an entity or an attribute, but let me give you an example which will hopefully explain it. If I was building a database for a car sales system, the entity car would almost certainly feature inside that database. But when I come to describe a car, I would use attributes to describe it. Things like the manufacturer, the model number, the engine size, the colour, the number of doors, the fuel type. There would be a whole long list which would be filled out and create an individual instance of the entity car. If I filled those out, and perhaps it was a Vauxhall Zafira 1.8 petrol, 5-door, red, etc., I would be creating a record, an individual instance of the entity car. So you can see that entities and attributes, similar types of thing, they're both data items, but they are placed at different levels. Relationships. We'll come to relationships now and see how they work. I'll start with an entity. I've got an entity here, I've called it student. I've given student 5 attributes: name, date of birth, address, telephone number, and date enrolled. And we'll look at those in a little more detail later on. But as I said, I want to focus on relationships. So inside our database, I think of another entity student might have a relationship with, and I might think teacher. So I think, okay, we've got a student, we've got a teacher. Now my job is to think about what the relationship is. So I start with one entity and I end with the other entity, and I come up with a sentence. Student is taught by teacher. Seems to be a credible sentence, seems to reflect reality. Yeah, that works. Now I flip it round. I start with the entity teacher and end with the entity student, and I try and put some kind of descriptor in between them that again will form a sentence. Teacher instructs student. Yeah, that seems to work. I'm happy with that. But there are 2 more elements we must bring into our sentence. Firstly, we have the idea of cardinality, relative amounts of entity A compared with entity B. The second thing we're going to have to think about is optionality. Must entity A always be related to entity B, or maybe only sometimes related? Take those 2 elements, put them into our relationship between student and teacher, and we might come out with a relationship that sounds like this. Student, maybe, is optional, taught by one or many teacher or teachers. Flip it around. Teacher, may, it's optional, instruct one or many, multiple, students. Seems to work. Notice here that I only use singulars for entity names. That is a data modeling convention. Don't use plurals. Moving this on a bit, let's look at the different types of relationship which can exist. The diagram shows 3 the list underneath immediately shows 4. Top diagram reads, graphically, A may be related to one or many B's. Reading the reverse way round, it says B must be related to one and only one A. Depending on which way round you read this relationship, it's either a one-to-many or a many-to-one. Fine. The second diagram shows an example of a one-to-one relationship, and it reads, A must have a relationship to one and only one B. On the reverse, B may have a relationship to one and only one A. An example of a one-to-one relationship. The final example is an example of a many-to-many relationship, where A may have a relationship to one or many B's, and B may have a relationship to one or many A's. A many-to-many, which is actually the situation we've got between our student and our teacher. One-to-many relationships are rather problematic. What they normally would imply is that we've missed a piece of information out. Many-to-many relationships, generally not true. Many-to-many relationships certainly don't work in relational databases, so they have to be resolved out. The diagramming technique we're looking at here with the various symbols of the crow's foot, the single strike and the round symbol, is an example of ERD models, entity relationship diagrams. Moving on, as I said, our student and teacher was a many-to-many relationship. It needs resolving. And the resolution always looks like this. First off, there is an entity which is sitting between our two candidate entities. We don't know what it is, but we know the relationship runs from student to this new mystery entity is one-to-many. We know the relationship that runs from teacher to this new mystery entity is one-to-many. We just don't know what it is. The second thing we can say, always, is that this mystery entity could potentially contain a date and time stamp. Whether it actually contains it or not depends on whether it's useful to our system, but it always has the potential to contain it. So what is this missing entity? In the example that I'm giving you here, what I think it probably is the register entry that the teacher takes when the student is present. The teacher takes lots of registry entries. Each registry entry is for one and only one student. It must be for one and only one student, and it must be taken by a teacher. The student will have many register entries for the various classes for which the teacher has recorded him present. So, there is our resolution. In reality, when analysing or designing a system with which we are not very familiar, working out what this linking entity is can be a tricky operation. Just remember that the cardinality involved is always the same, and always remember that the missing entity could take a date and time stamp. Now, let's move on a bit and try and have a look at our attributes. We came out of a list of 5 attributes for student, and I came out with them in quite a glib, short manner. There is a subject called normalization, which would take that attribute list, or indeed any attribute list, and try and ensure that it is logically consistent for the rules of a database. Now, there are effectively 3 rules of normalization which are commonly used when checking a list of attributes. The rules of normalization are probably a bit too complex and involved to go into in depth inside this screencast, but they are included inside the textbook. All I'm going to say for the time being is that normalization rules are applied to attributes, which belong to entities, to make sure that they are consistent and belong to that entity. The 3 rules are: rule number 1, remove repeating groups; rule number 2, remove part key dependencies; rule number 3, read non-key dependencies. And with that very short and inadequate explanation of normalization, I'm going to leave it there. I'm not, however, going to leave attributes. I want to talk finally a bit about a thing called a data dictionary. And the data dictionary is where we record the attributes that belong to an entity. In the example I've got here, we have a student, and I've given the student a dictionary style definition, an individual who has a current enrollment on at least one course. You will find that words take on incredible meaning when looking at data modeling. Everybody on the team, everybody involved with the database or the data development, whatever the exercise is, must have a very, very clear and unambiguous understanding about the words that are being used, which is perhaps why I'm being so pedantic about defining entities and their attributes of key importance. You will see that the list of fields or attributes which have been associated with the entity or table student has been increased by one. We have an additional one at the top called student ID. This is the unique identifier of an individual record. It is, if you look at the final comment column, called a primary key. Primary keys exist for all records inside a given table, or should we say for all occurrences of an entity. The primary key must be unique. It is a unique identifier. It should never ever repeat. If you go back to our example of a car, the primary key for our entity car on our car forecourt would of course be the car registration number. If there are two cars driving around the UK with the same registration number, well, one of them is a wrong one. And so it is with any primary key. It is a unique identifier of a record. The other characteristics we describe inside the data dictionary are things like the data type. I'm using numeric, text, and date timestamp for my data types. There are others, such as booleans. That is contained inside the textbook. I would ask you to refer to that. Column 3 refers to the length, how long is the field, or indeed attribute. The fourth column refers to whether a value must be included in the record or whether it may be included in the record. It's worth noting that student telephone number is an optional field. Maybe the student hasn't got one, whilst as the student name and address is a mandatory field. We must have it. The next column refers to the format that the field adopts. We have two formats here, they're both the same, and it's a day, month, year format for a date. There's no effective formatting being applied to any of the other fields. And finally we have our comment field, which tells us about the primary key, and it might tell us other interesting information that we might want recorded against the other fields. Every entity inside our system should have a data dictionary record like this. So, to sum up this very, very brief course in data modeling, it is important that you learn to distinguish the difference between entities and the attributes that describe them, even though they're both data objects. Normalization is a technique which helps create a logical list of an entity's attributes. Not every entity is connected to every other entity. The connections between entities is something which again needs further exploration. We'll be exploring a second type of key called a foreign key, and that will be done inside the textbook. And finally, wherever we have a many-to-many relationship, this seems to imply that we've missed some data out, and that relationship will need resolving at some point during development. Okay, this has been a very, very quick blast through data modeling. You'll have to read the considerably fatter chapter inside the textbook which relates to data modeling. There will be a further screencast on this topic. Thank you very much for watching. That's the end of this screencast.